Okay, so this is the muscles scene file, and it doesn't have any animation on it at the moment. It's just our standard muscle rig that we would deploy into shots. And so what I need to do now is import in both the animated joint hierarchy that I was showing earlier, and also the alembic cache of the bones that we cached out as well. So I'll get the joint hierarchy first. And that has dropped itself into the inputs group, so we're going to unparent that. And then I'm also going to bring in those bones. Martial arts run up bones. Cool. I'm going to set the timeline to start at 990. I'm going to switch the solver off for now. But I'm also going to set the start frame to 990 because when we do start to simulate, when we turn the solver back on after we've done some things, we are going to want it to start from 990. So it's important that you set that as well. Okay. So in Ziva, when you're simulating our dynamic objects, everything is relative to the solver position. So if I just grab the solver and I set interactive playback on or whatever and just started moving this around, you would see the tissues move because they're effectively moving relative to the world or to the solver. So we can leverage that feature in that if we move the character, the bones, in this case, and the solver at the same time, effectively moving them in lockstep, you can negate all the world space inertia that would enact on the dynamic objects if you didn't move the solver. Like if you didn't move the solver and you tried to move the character into world space over one frame, like we've set up, it would just rip it apart, right? It'd be too much force for the solve to handle. But if we move the solver at the same time, we can negate all that, which is quite cool. So the first thing I'm going to do is move the solver with the rig. That's why we import the joint hierarchy, so that we can do that. So I'm going to select the root joint of the rig first, and then I'm going to parent constrain the solver to it. So constrain, parent, I'm going to make sure translate and rotate are on, maintain offset is on, apply. And then we don't want the solver to carry on moving for the rest of the shot, we just want to move it on the first frame. So in order to do that, I can bake keys, simulation, grab these in the channel box, start and end you need to set to 990 and 991. There's lots of ways of moving the solver. You could, if you have a snap script or whatever, you can do that as well. This is just one way of doing it. Okay, and then I'm going to delete that parent constraint. Cool. So you see now that the solver is still switched off, but we can still check that everything's moving correctly. I can jump forward one frame and see that the bones and the solver move in lockstep, and then going forward the solver does not move, but the bones and the joints carry on moving. That's great. The next thing I'm going to do is I'm going to set substeps. I'm going to remember that it was at 4, and I'm going to set substeps to 1. And this is a very important part of the pre-roll, this part of the pre-roll, because if I was to jump to, say, frame 990.5 at this point, you're going to see that things get pretty weird on those subframes, and we don't want Ziva to be looking at these subframes and trying to simulate that, right? Because you'll get a total mess. So it's very important that we're on one substep for the world space jump to avoid all this stuff. So thankfully substeps are keyable. So on frame 991, I'll set a key here, and then on frame 992, I'll set it back to 4. And that way we ensure that the jump happens in one substep, and then from there we can do our normal roll into 4 substeps. Cool. The last thing we need to do now is connect our driver bones, which we imported earlier, to the corresponding Ziva bones. So I have a little script for that. First thing I need to do is, add a suffix. This is just my personal script to do this. You might have another method for connecting your alembics to the Ziva bones. I'll just show you how I do it. So, oops, that was a prefix. Okay, and then, so I have this little routine here, which you're welcome to copy if you want. So it's just going to take a list of objects, a start and end frame to set keys on blend shapes, and then a suffix to help it look for the corresponding stuff. So I'm going to take the current selection, and I want my keys to be set on 990 and 991, and it's going to use the driver suffix to help do the selection. Okay, so now when we jump, you're going to see that the Ziva bones move as well, which is exactly what we want. And so now at this point I can switch the solver back on and hide the outliner, and if I jump one frame here, everything moves and nothing ripped apart. So if I was to carry on simulating this now, it would look like this scene that I prepared earlier, which I've already cached. And you can see that the jump happens and then we roll into the start position seamlessly, and then the shot starts. Cool, so that's basically it for pre-roll. The process again is the same when you come to do the skin or the fat. So the process is exactly the same, except you also import the animated muscles as well as the alembic cache for the bones, and also obviously the joint hierarchy so that you can parent the solver and make sure it jumps correctly. Yeah, so that is how to do run-up or pre-roll. Thanks everybody for watching, and as always, if you have any questions on that, feel free to email us at support@zivadynamics.com, or of course post questions on the community and be involved in that. Thanks very much.